Hi Trig students, this is your study guide video. This is going to be very similar to your test 3 for chapter 8. Remember, chapter 8's only over 4 sections, so 8.1, 8.2, 8.3, and 8.4, and it's going to be a mix of all of this triangle information. So let's go through the study guide. The test is going to be 15 questions, but your study guide has 17 because the test is coming from a test bank. And so there are 17 possible questions in the bank, and then it will choose 15. And so I thought it would be best if we just covered all 17, and depending on which questions you get, you will be prepared. So this is what it's going to look like. It is on MyMathLab, so it's going to be that same format. And here we go. Let's just jump right in. So the first question says, solve the following triangle using either the law of sines or the law of cosines. Okay, well, I like to draw a triangle first of all. So I'm going to draw my triangle. I'm going to use standard labeling, which means A, B, and C that way. Here are my sides directly across. And then I'm going to put in my given information. So I'm given that B is 65 degrees, C is 34 degrees, and side A is 5. So I notice here that I have an angle, side, angle situation. Okay, basically what that tells me is it's not the ASS situation. So this means I'm going to have one triangle only. So down here are my answer choices. I know I'm going to have one triangle, and I know I'm not going to have two triangles. So I'm only going to have one triangle since it is the SAS situation. Remember, when it becomes, where you have these as choices, is that angle, side, side situation. And so that's what we have to look out for. But that's not what we have here. Okay, so now we have to decide, are we going to use the law of sines or the law of cosines? Well, the first thing I notice is I have two angles. Okay, so I can find angle A because I know all three angles have to add together to give me 180. So if I do 180 minus 34 degrees minus 65 degrees, I learn that A is 81 degrees. Well, that's already one of my answers. There we go. And by the way, I do not have to put in that angle sign in MyMathLab. I'm just putting in the numbers 8, 1. Okay, and I know this is going to be my answer. All right, now I have to decide, do I use law of sines or law of cosines? Well, here's the rule. You are always going to use law of sines if possible. So what does if possible mean? That means if you have all the information for one letter and a piece of information for that second letter. So it turns out I have all the information for A now, and I have one piece for C and one piece for B. So I'm going to use the law of sines. It's just easier. Okay, so I'm looking for side B, or you could be looking for side C first. It really does not matter. The only time you have restrictions is when you're looking at angles. So we are okay so far. We're just finding sides, so you can find either one. If I want to find side B, it goes on the top, and the sine of 65 degrees goes on the bottom. I'm going to set that equal to my A information, 5 over the sine of 81. Okay, remember to have your calculator in degree mode. You're going to do 5 times the sine of 65 degrees, hit enter, divided by the sine of 81 degrees, and you're going to get that B equals 4.59. Okay, they don't list it here, but they like in MyMathLab for your sides to have 2 decimal places. Make sure that you do that. I will be going back through your tests, making sure you didn't miss an answer because of a decimal place or one digit off or something weird like that. So I'm going to check you, but just pay attention to your sides. Now your angles, they normally will just let you round it to a whole number or do one decimal place. So keep that in mind. Read your directions. Okay, for C, here's C on the top, sine 34 degrees on the bottom. We're going to have our A information. Okay, remember you put what you're looking for on top. We're going to do 5 times the sine of 34 degrees, hit enter, divided by the sine of 81 degrees, and you get that side C is 2.83. Put that right in your little box and you're done. So that would be very similar to one of the problems on the test, just like that. Okay, all right, let's keep going. Let's look at number 2. Okay, number 2 shows a right triangle. I know it's a right triangle because I see the little box over here, and we've got that 90 degrees there. Okay, so we want to use the triangle given to solve it. All right, so we know side B is 7, and we know angle A is 80 degrees. Okay, and here we have very clear instructions as far as decimal places, so that's good. All right, well, since I know 2 sides, I can easily find side B. So that's what I'll do. I'm going to have 180 minus 90 minus 80. B, whoops, comes out to be 10 degrees. Remember, I only need 10. Now it says as needed. That means if you have decimal places, you can round. If you don't, you can leave it alone. So I can leave it as 10, or I can write it as 10.0. Okay, that's what the as needed means. All right, now that I have B, okay, I have all my angles, I need to find these 2 sides. Okay, it's a right triangle. So you have 2 choices. You have Pythagorean theorem. Well, that's not helpful because I only have one side. Or you have all those trig relationships that we learned, the SOHCAHTOA relationships. So if I stay with the angle that was given to me, just so I'm absolutely positive I didn't mess anything up, then I have the adjacent side. And if I want to find the opposite side, okay, adjacent and opposite mean a tangent situation. So if I take tangent of 80 degrees, and by the way, you could have used the 10 degrees, you could have used all kinds of different ways to solve this. You could have immediately gone and solved C and then done a Pythagorean theorem. I mean, the options are endless. So as long as you get the same answers that I do, you're good to go, okay? All right, so tan of 80 is going to be the opposite, that's my A, over adjacent, that's my 7. Now I multiply these 2 together, tan of 80 degrees times 7. I'm rounding to 2 decimal places, and I get 39.70. Okay, now I want to find C. Well, you have B and you have A, so you could use the Pythagorean theorem and find C. Easy enough. Or you can use your SOHCAHTOA relationships. Here I see that I have 80 degrees. I'm looking for the hypotenuse, and I have the adjacent. Okay, well, adjacent and hypotenuse is a cosine relationship. So cosine of 80 is going to equal adjacent over hypotenuse. Now, when what you want is on the bottom, things are a little different. Here, all we did was multiply. We just multiplied those, and we came up with the answers. Here, I can't do that. I have a letter in the bottom. So instead of multiplying these, you're going to switch them. You're just going to switch them. you're going to get C equals 7 over cosine of 80 degrees. And we had learned that before spring break, so that's not anything new. Okay, now we're just going to do 7 divided by the cosine of 80. 7 divided by the cosine of 80 is 40.31. And that's your C. And again, you could have gotten that answer if you had done a squared plus b squared. Add those together, take the square root, you would have gotten the same answer for C. So any way you want to go about that is fine. Just make sure these are your answers when all is said and done. All right, we have another right triangle here. This one has the sides A and B. We could even put a C over here. We know that's a hypotenuse. And I notice all I have is theta, just a little theta. Okay, I also have the values of these two sides. And I'm told to find the value of the 6 trigonomic functions of the angle theta. So what that means is if I was sitting in this corner, from this angle, what would all 6 trig functions be? Well, that's your SOHCAHTOA and then the reciprocals of SOHCAHTOA. Well, we're going to need C in order to complete this. So we are going to have to use Pythagorean theorem here. We're going to have 7 squared, that's our A squared, plus 5 squared, that's our B squared. That's going to give us 49 plus 25, that's a 74. I'm going to take the square root of each side, and the square root of 74 is C. Now that's an ugly answer. Yours is going to be ugly on the test too. You're not going to be able to reduce it. There you go. Square root of 74. All right, now if I'm sitting here in this corner, let's go through our trig functions. So we know we have SOHCAHTOA. All right, let's do sine first. So sine of theta is going to be opposite over hypotenuse. All right, well, you know we can't leave it like that. We are going to have to rationalize. So we're going to take the square root of 74. We're going to multiply the top and bottom by that. We're going to end up with 5 square root of 74. Multiply these together, you get 74. And there's sine theta. Okay, we can't cancel these because this is under a radical. All right, so we did the so. Let's do the co. So we're going to look at cosine of theta is going to be adjacent over hypotenuse. All right, again, we have to rationalize. This should be the last time we have to do that. We get 7 times the square root of 74 over 74. There we go, best we can do. That's our cosine theta. All right, let's do the TOA. We have tangent of theta is the opposite over the adjacent. So the tan of theta is 5 over 7. Okay, so we use SOHCAHTOA to find the big 3. Now all we have to do is find their reciprocals. So the reciprocal of sine is cosecant theta. Now, we don't want to just grab our final answer for sine and flip it, because if we do, we're going to be rationalizing with some really big numbers. If we go back here to what sine theta originally was, and we take this reciprocal, then magically we aren't going to have to do anything because our radical is in the numerator. Now, you could have taken this, flipped it, you would have had to rationalize it. It would have been a lot of reducing, a lot of big numbers and simplifying, and you would have come up with the square root of 74 over 5. But sometimes it's just easier to go all the way back to the beginning and look at what the original answer was before rationalizing and flip. And then you have the answer. So that's just a little trick there to make your life easier. Let's do the same thing with the reciprocal of cosine. So that's secant theta. We're not going to use this big boy because that would be a lot of rationalizing once I flip it. If we go back to the original cosine and I flip that, lo and behold, I didn't have to do anything. And then cotangent's going to be nice and simple. If we flip 5/7, we're going to get 7/5. And those are all 6 of the trig functions of the angle theta. Okay, so remember your SOHCAHTOA, remember your reciprocals, and you're good to go. Okay, next problem. All right. So we have another situation here where we have to decide, do we have a single triangle, 2 triangles, or no triangles? Okay, we're given 2 sides and an angle. Well, we've got to figure out where is that angle located, because that's going to make all the difference in the type of triangle we have. So let's draw it. Here we go. I'm going to do my standard labeling. Okay. In this case, here's my angle. Here's a side. Here's a side. Okay. I do not have a side angle side because the angle is not included between them. I have an angle side side. All right, folks, this is it. This is what we've been training for, right? This is the really terrible one where we have to be very, very careful. We don't even know if we have a triangle. And if we do, we may have 2. So, first thing we're going to do, we're going to check for 1 triangle. We got to check and see if we even have a triangle. Okay. Well, I notice that I'm going to use law of sines. Remember, SOHCAHTOA is off the table. This is not a right triangle. Pythagorean theorem off the table. This is not a right triangle. You're now dealing with law of sines with one of these crazy type triangles. Also, you know it's law of sines because of all the information for B and one little piece for C. So I'm going to try to find angle C. So sine C on top with 6 on the bottom equals sine 30 degrees on top and 5 on the bottom. I'm going to multiply 6 times the sine of 30 divided by 5. Now that's not your answer for C. Remember, that's what sine C equals. Now I'm going to have to take second sine or inverse sine to get the angle. And it turns out angle C is 36.87 degrees. All right, so it turns out we do have at least 1 triangle. We do. So no triangles is not an option. We either have 1 or we have 2. Okay, well, let's finish. We know we have at least 1. Let's finish with that 1. And then we'll look a little farther and see what else we have. Okay, so if I want to find A now, I'm going to do 180 minus 30 minus the 36.87 degrees. And A turns out to be 113.13. Okay, and I'm not really following any decimal place requirements right now because I didn't put them on here, so I'm not really sure what I have. Okay, last thing I need is side A. Okay, so I'm going to use my given information here. I'm going to put side A on top and sine of angle A on bottom equals side B on top, sine of 30 degrees on the bottom. I'm going to do 5 times the sine of 113.13 equals divided by sine of 30. And I come up with side A. All right, I did it. I found all the information for 1 triangle. Now we have to check and see, do we have a second triangle? Here we go. We're going to check for a second triangle. All right, to check for a second triangle, first thing we're going to do is check for a second angle C. We're going to follow the order that we did for the first triangle. So we found a C for the first triangle. I'm going to check for a C2. to see if there's a C2. To do that, I take 180 minus C1. That would be this guy right here. So 180 minus 36.87 degrees. Well, look at there. I do have one. It's not a negative value, so that's a possibility. Okay, I'm not convinced yet. There's one more step. We have to check for an A2. To check for an A2, you're going to take 180 minus the B that was given, minus this C2 that you just found. So I'm going to do 180 minus 30 minus 143.13. If this is positive, we have a second triangle. If it's negative, we only have the 1. Okay, well, it's tiny, but it is in fact a positive number. So we have 2 triangles. Here's all the information for the first triangle. Now we're going to find all the information for the second triangle. Okay, so we found C2, we found A2. Now we have to find little side A2. Little side A2. We're going to follow the same pattern here, not with the sign of angle A, but with the sign of A2. Now we're going to keep our B's because those certainly don't change. Okay, we're going to multiply and divide, and we end up with 1.20 for A2. Okay, so make sure that you understand how this works. You're checking for the one triangle just like normal. As long as you get values, you have a triangle. To check for your second triangle, you just follow the order you did for your first. So we're going to try for C2. We do 180 minus C1. Okay, it was positive. Then we try for A2. 180 minus the given angle minus the C2. It was also positive. That's what told us we have 2 triangles. And then we use this new value to find for the new side in that second triangle. Okay, now we need to put them in our answer blanks. So make sure you read this carefully. 2 triangles are produced where the triangle with the smaller angle C has these values. So find angle C. Here's C1, here's C2. Which one is smaller? C1. So all of the 1 values are going to go into the first blanks. Okay, the triangle with the larger angle C, that was this one, are going to go into these blanks. Okay, so make sure that you read that carefully and that you pay attention to who goes where. Smaller C, all of those go here. Larger C, all of those go here. And then you're good. Okay, that was the most difficult problem on the test. All right, here we go. You are going to have 2 word problems. Here's your first one. All right, here we go. We got Brandon and Antonio. They want to determine the height of a tree before cutting it down. Well, that sounds safe. Okay, because they want to make sure it doesn't fall on Rebecca's fence. All right, so the angle of elevation of the tree from one position on a flat path from the tree is 70 degrees. From a second position, 40 feet farther, it's 60 degrees. What is the height of the tree? Do not round until the final answer, and then round to the nearest tenth. All right, well, we need a picture. So here we go. Let's draw a tree. Let's say this is the tree. I'm not drawing the big fluffy thing on the top. Let's just say it's a big dead tree. And that's as far as it goes. Okay, here's our path, okay? All right, so the angle of elevation from the tree from one position on a flat path from the tree. Okay, and let's pretend this is a really tall, sturdy tree. So look at there, we got a right triangle. This is 70 degrees. This is H. Okay. Then there's a second position 40 feet further along this path. All right, so our path is going to continue. Okay, that's not beautiful, but let's say this is 40 feet further from H. We have point B, and point B is 60 degrees. Okay, we want to find this little h, which is the height of the tree. Okay, so basically what we have here is two triangles. We have a right triangle, and then we have this funky little oblique triangle off to the side. Okay, so I'm going to name this triangle 1, and I'm going to name this triangle 2. Now, there are a lot of different ways you can get the answer to this problem. So if you have a clear path in mind, you jump right in, because all we want is the answer. Okay, that's all you're being graded on, is the answer. But if you need a little help, this is how I handled the problem. Okay, so I'm going to take this first little triangle, and I'm just going to kind of bring it up here out of the way, and I'm going to draw it. Okay, here it is. All right, I should have drawn it a little bigger, but I didn't. Here's B, here's H. Okay, that means this would be little side B, right? Okay, there we go. All right, what do I know from this? I know that this piece is 40. I know this is 60 degrees. Well, I can't do anything with 2 items. I need a third item. Well, let's look at the original here. This is a 180-degree path, and I know this angle is 70 degrees, which means I can also find this angle right here. So I can do that because 180 minus 70 is 110 degrees. So I happen to also have that. Look at there. All right, so that's perfect. I also have that piece of information. Okay, what I am trying to do here is I am trying to find H. And if I could have one other piece of information, one other side, I could use SOHCAHTOA to find H, because I already have 70. Okay, so I have the opposite side. If I had the hypotenuse, then I could use a sine relationship and find the answer. So I really would like to have this side right here. So I pulled this triangle out. It's this side I'm looking for, right across from angle B, which would be side B. That's really what I need. And so what I notice here is that I could find this because I have 60 degrees here. If I knew this angle up here, I could use law of sines. Well, in order to find this little angle, I know it would be 180 minus 60 minus 110. And that ends up being 10 degrees. Okay, now I have all the information for this in one piece for B. So if I put B on top, sine 60 on the bottom, 40 on top, sine of 10 on the bottom, I can use law of sines to find this side, which is the hypotenuse of this right triangle. So when I do that, ooh, I get a big number, but it said don't round, so I'm just bringing it on out quite a few places there. Okay, that's what I end up with. So I'm going to label this little b. Okay. All right, now if I take that right triangle, okay, this is 70, here's H, okay, and this is 199.48966, okay, and I have this. Because it's a right triangle, I can use SOHCAHTOA. So if I sit here, I want the opposite. I have the hypotenuse because it's across from the right angle. That's a sine relationship. The sine of 70 degrees is opposite over hypotenuse. Multiply those together, round to the nearest tenth. Happens to be in feet. You don't need that, I don't think. And there's your answer. It's kind of out of the picture. There you go, 187.5 feet. All right, so I don't think it'll fall on Rebecca's fence, so Brandon and Antonio will live to chop down another tree. But there we go. You're going to have this problem. It's not going to talk about our classmates, but this will be what you have with these 3 pieces of information. This is how you're going to go about doing it. So practice, practice, practice. Make sure you can draw the original picture. If you like the way that I did it, you're first going to take out the oblique triangle. You're going to solve for the other angles. You have clues to do that. Law of sines will help you get this side B. That ends up being the hypotenuse of your right triangle. And then you use the sine relationship from SOHCAHTOA to get the height of your tree. Okay, so a couple of combinations there will help you do that. All right, let's go down there and look at number 6. We have another right triangle. All right, I noticed that B is 7 and angle B is 17, and it wants us to find the rest of the information. Okay, well, I have 2 angles. I can find the third. That's always my favorite thing to do because it's so easy. Okay, turns out angle A is 73 degrees. All right, again, it says round to the nearest tenth for the angle if needed. I didn't need it, I got a whole number, but if you want to put 73.0, that's fine too. Okay, now I need the other 2. All right, well, I can use what they gave me as my key relationships in SOHCAHTOA. Okay, so if I am sitting here at 17, I have the opposite, okay, and I want to find the hypotenuse. That's a sine relationship. Sine of 17 degrees equals opposite over hypotenuse. Now again, I can't multiply these like I'd like to. That means we switch. Put the C out. 7 over sine of 17 degrees. C ends up being 23.94. Okay, now it's time to find A. You can use Pythagorean to do this. A squared plus B squared equals C squared, or you can stick with SOHCAHTOA, whatever you'd like to do. I'm just going to stick with SOHCAHTOA here. So now I'm looking for adjacent. I have opposite. Okay, well, opposite and adjacent, that's a tangent. Opposite is 7 over adjacent. Okay, well, that's not really what I want because I'm going to have to switch these. I can't multiply them. Put the A out, 7 over tangent of 17 degrees. A ends up being 22.90. And there's the answer. And if you had done Pythagorean, you would have gotten the same thing. Okay. All right. We're done with right triangles for a little bit. Let's look at number 7. We already have a triangle drawn for us. All it says to do is solve. Okay, well, it doesn't hurt to just make sure we're not dealing with the ASS situation. We have an angle, an included side, and an angle. So we are good to go. We will have one and only one triangle. So I don't have to worry about that. Okay, based on the information I have, I'd like to find angle A first. So I'm going to do 180 minus 78 minus 9. A is 93 degrees. Again, you don't have to put the degree sign in MyMathLab, just the 93. All right, well, I definitely did not draw this to scale, did I? Okay, now we have all the A information, and I want to find the 2 remaining sides. So I'm going to use law of sines. Since I have all of A, I can choose either one of these. Okay, so I'm going to go for B. B over the side of 9 degrees equals 16 over the sine of 93 degrees. Okay, and B is 2.51. It said to round to the nearest, round to 2 decimal places. There we go. We're going to do the same thing with C. We put it on top, it's what we want, over the sine of 78 degrees equals 16 over the sine of 93 degrees. We multiply, we divide. Sine is C is 15.67. And there we go. We solved it. All right, here is your second word problem. It's a golf shot. I know Dayton golf, so I threw her in here, but then I realized it's about a golfer who hit it in the rough. So that is not Dayton because she's fabulous. But let's say Dayton hits an errant tee shot that lands in the rough. Okay, a marker, here's your marker, in the center of the fairway is 130 yards from the center of the green. While standing on the marker and facing the green, Dayton turns 100 degrees toward her ball. She then paces off 40 yards to the ball. How far is the ball from the center of the green? This is what you're looking for, is this value right here, this side over here. You have a side, angle, side situation, which we know is a good thing because it's only one triangle. Okay, and yes, you're going to have this little picture right on your test. I just copied and pasted it into the study guide, but you're going to have that exact photo, so you don't have to worry about it. Okay, I do kind of like to draw it away from all this other stuff that's on here. Well, that is a terrible looking triangle. Hold on. It wouldn't be Miss Holcomb's study guide if she didn't draw something really wacky, right? All right, how about that? Is that better? Okay, so let's label him. Let's do A, B, C. We know this is 100 degrees. Ooh, that is bad. 40 and there's 130. All right, you're gonna live. Okay, there's C and there's B. Okay, boy, I apologize for that. So now, this is all the information I have. I cannot find another angle because I only have one. And I cannot use law of sines because I don't have a single letter that has all the information. I have to use the law of cosines. This is the first time we've had to do that so far in this study guide, but we have to here because I don't have a choice. I cannot use law of sines. I don't have all the information for a single letter. All right, so what am I going to do? Well, there's only one side to solve for, and that's A. So if I look up my law of cosines for A, this is what I have. I have A squared equals B squared plus C squared minus 2BC cosine of A. And that's perfect because this is the information that I have. Okay, so B is 130. We're going to square him. Plus 40 squared minus 2 times 130 times 40 times the cosine of 100 degrees. Okay, if we square both of these and add them together, you're going to get 18,500. 2 times 130 times 40 is 10,400. And there's cosine of 100. Okay. So if you take 18,500 minus these two items multiplied together, you're going to get that A squared equals 20305.94105. I just kept all my values. I thought I'll round at the end. Now, I take the square root of each side, and it turns out A is 142.5 yards. And that's exactly the value I wanted. I wanted this side of the triangle. So that is your second word problem. You're only going to have those two. You're going to have the tree that chops down, and you're going to have the golfer. And that's how you do both of those. Okay, and you don't have to solve for the rest of the triangle because all we wanted to know was how far that ball was from the green. We just wanted that side of the triangle. So that's it. All right, number 9. Okay, we have a right triangle again. A right triangle, well, we don't have a picture. Let's draw a picture. Okay, with a right triangle, you got to be careful because the hypotenuse is always C, right? And then the others you can label any way you want, but it's a little different than standard labeling. Okay, a right triangle has a hypotenuse of length 5 inches, okay? If one angle is 43 degrees, I'll just pick A. Find the length of each leg. Oh, okay. So we want to find A and we want to find B. All right, well, it doesn't ask for B, angle B, so we actually don't even need to find it. It's not necessary because with a right triangle, we have SOHCAHTOA and we have an angle to put into SOHCAHTOA, so we're good to go. All right, if you wanted to find B, you certainly could, but it's not part of the answer. Okay, so if I'm sitting here and I have a hypotenuse, well, opposite would give me A, and my hypotenuse, that is a sine relationship. So the sine of 43 degrees is the opposite over the hypotenuse. If I multiply both of these together, A turns out to be 3.41. Okay, now if I'm sitting here, I'm looking for adjacent, and I have a hypotenuse. That's a cosine relationship. Adjacent over hypotenuse. Multiply. It's going to give me B is 3.66. Okay. Now, as I look at my answer blank, be careful here. It tells me the length of the shorter leg is blank. Okay, so it doesn't say A or B because remember, I'm the one that labeled those. But the shorter leg is 3.41. That's the smaller number. Wants us to round to the nearest tenth, so 3.4 goes in that blank. The longer leg, well, the bigger number, 3.66, wants us to round. I'm going to round him to 3.7. Be careful on this problem. It's a simple little problem, but you can end up missing it or getting points taken off because you didn't read the directions for the answer. So be real careful on that. Okay, number 10, solve the following triangle. Well, it didn't say it was right, so let's do a standard label. Tells us A is 30 degrees, B is 30 degrees, and side C is 10. This is an angle, side, angle, which means we have one triangle. So we don't have to worry about anything crazy. Okay, now it wants us to find the rest of the triangle, solve the rest of it. Okay, well, first thing I can do is solve for C. I can do a 180 minus a 30 minus a 30. Okay, well, I just saw something pretty interesting there. I don't know about you. But did you notice that these angles are exactly the same? What does that mean for their sides? Well, they're also going to be the same. So I actually didn't draw this correctly at all. The way that it should have been drawn is this. Since A and B are equal, little a and little b are going to be equal. That means it's an isosceles triangle. It's an isosceles triangle. Now that's just a little fun fact. All that means really is that you only have to solve for one of these sides because the other side is going to be exactly the same. So just pick a side. Well, let's see. Let's solve for A. So if I do a over sine of 30 equals 10 over sine of 120. And by the way, I chose to use law of sines because I had all the information for C. So that made it easy. Okay, A turns out to be 5.77. Any guesses as to what B is going to be? So B is also going to be 5.77. And you can do that to check it if you want. You can go ahead and solve for B using law of sines, or you can just realize it is an isosceles. They're going to be the same. So you're going to have one of these on your test as well. And that'll save you a little time if you realize that it is an isosceles. Okay, here we go. Number 11. All right, so we have this little triangle here. We have all the sides. We don't have any angles. So because it is a side, 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 I do know this means I have one triangle. So that's exciting. At least I don't have to worry about the two or the none, right? Okay, now a side, side, side triangle does present us with one extra issue that you have to be aware of. All right, well, first of all, can I use law of sines? No, because I don't have a single letter with all the information. I don't have any angles, so I have to use law of cosines. And I'm gonna do that first. And I say first because I'm going to switch to law of sines as soon as I can, just because it's a lot easier. All right, here's the trick. All right, we are going to do law of cosines first, but you have to know which angle to solve for. You have to solve for the largest angle. That is important because law of cosines is for obtuse angles only, not for acute. So you've got to solve for the largest angle. How are you going to know which one's the largest angle? It's the one that has the largest side. So don't let my drawing throw you. Because this is the largest side, A is going to be the largest angle. Okay, that's going to be the largest angle because it's opposite the largest side. All right, so that's the first thing that we're going to do. We're going to solve for side A. Well, there's only one version of the law of cosines that contains angle A. And it's that. I should have given you more room for this problem and I didn't, so I'm trying to squish it all in. All right, here we go. A squared, that's 7 squared, equals 3 squared plus 5 squared minus 2 times 3 times 5 times cosine A. I'm just putting in everything I have. All right, then I'm going to have 49 equals 9 plus 25 minus 30 cosine A. If I add 9 and 25, I get 34. If I subtract the 34, I get 15. So 15 equals negative 30 cosine A. Now I'm going to divide both sides by negative 30. This is negative 0.5 equals cosine A. Now don't forget, in order to solve for A, you're going to have to do inverse cosine. You're going to have to do second cosine, that inverse cosine. What you're going to find is that A equals 120 degrees. Yep, an obtuse angle. That's what we thought. Okay. All right, so now that we have A, now we're able to switch over to the law of sines. Okay, now we're able to switch over. But the key is we're going to solve for the smallest angle, just to make sure that everything is okay. So if I look at 3 inside 5, I realize B is going to be the smallest angle. Okay, so that's what I'm going to be solving for. So I'm going to put sine of B on top and a 3 on the bottom. I'm going to put sine of 120 on top, 7 on the bottom. That's going to give me a sine B of 0.37115. If I take second sine of both sides, I get B is 21.8 degrees. Notice I needed that 1 decimal place for him. And again, I know I keep writing these degrees on here, but you don't need it in MyMathLab. Okay, last but not least, to find angle C, we simply use the law of triangles. 180 minus 120 minus 21.8. C is 38.2 degrees. And that's the third one. Okay, so you will have one like this where you have side, side, side. When you have side, 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 use the law of cosines first on the largest angle. Make sure you can do this math. This is just calculator work. Make sure you're comfortable with it. Once you get that angle A, then you can switch to law of sines. Use your smallest angle, solve for that angle, and then use your law of triangles to get the third. All right, that brings us to number 12. Number 12 is so easy. It's nice to have a nice, easy one. When you see sine and cosine with angles together like that, what they're talking about is the complementary angle theorem. If these angles add to 90 degrees, they're complementary. And sure enough, 66 and 24 equal 90 degrees. So since they do, the ratio of these, it could have been cosine 24 over sine 66, or it could be the way that you see it here. But when these add up to be 90, the whole thing is 1. It's just 1. That was something we did way back in section 8.1. I think it was on the very front page of that packet, down at the bottom. So very simple. If you do put it in your calculator, it's not the end of the world. No one's going to know. You're still going to get 1. But when you do see it on the test, don't waste time. Just put 1. You're good to go. All right, number 13. Okay, well, from the looks of this, I can already tell we might end up with that ASS situation. Let's see if we do. Okay, let's draw our triangle. We have our information. I'm going to do standard labeling. Side A is 8, side C is 2, angle C is 160 degrees. All right, sure enough, angle side, side. All right, be careful, be careful, be careful. Here we go. We could have 1, 2, or none. We need to be very careful here and see what we have. First thing that we need to do, check for 1. We gotta check and make sure we have 1. All right, so I have all the information for C and 1 piece for A. So let's solve for angle A. So sine A over 8 equals sine of 160 over 2. We're going to multiply, we're going to divide, we're going to get sine A equals 1.368. Some of you might already know what's about to happen. Take the second sine, inverse sine, and what do you get? Error. It does not exist. We don't have a triangle, folks. No triangle. So on MyMathLab, you're going to click the bottom one that says there are no possible solutions. Now, the reason I said some of you might have already known that is because when you get to this point, remember, The sine and cosine of any angle, they can't be larger than 1. So that was the key right there. But when you put it in your calculator and your calculator freaks out and says error, that's what that means. Okay. All right, let's try again. Oh, look what I see. So, okay, let's see what we have here. All right, we are going to draw a triangle. We're going to do standard labeling. We have C is 100 degrees, B is 8, side A is 6. Okay, I have side, angle, side. Oh, they tricked me. I don't need all this stuff. Side, angle, side, that's not an ASS. I have one triangle only, so I don't have to worry about these two options. All I have to do is solve it. So be careful. You never know. Sometimes they'll do that. I just copied these right off of there. So here we go. Okay, so this is another way for us to practice that harder problem. Okay, so I cannot use law of sines because I don't have all the information for any particular letter. I want side C. So I'm going to have to use law of cosines, and I am going to use the one that solves for side C. So when I look it up, remember, have all that available, that's the version I'm looking for. Okay, I'm just going to plug in what I have. So I have 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 100 degrees. Okay, go ahead and put all that in your calculator. You end up with a C squared equals 116.6702. Take the square root of each side. You get C equals 10.80. There's your side C. All right, I can put that right over here. All right, now that I have that, I'm going to switch over to the law of sines. So this was my first step. I found side C. I wasn't worried about the largest of anything. I was just simply finding side C because that's the one that was left for me to find. Now I'm going to switch over to the law of sines. When I do that, I'm going to find the smallest angle. So if I look at all my sides, angle A is the smallest. Remember, law of sines was designed for acute angles. So I'm going to switch over. I'm looking for sine A over 6 equals sine 100 over 10.80. That's going to give me sine A equals 0.54716. Do inverse sine. A is 33.2 degrees. Okay. And then, last but not least, I can use that law of triangles to find B. It's going to be 180 minus 100 minus 33.2. Scoot it over a little bit so you can see that. B gives us 46.8. And we solved it. Okay, so make sure you're comfortable with law of sines and the law of cosines there for both of them. All right, well, we're almost done. This is the end. 3 more problems here. Oops. Okay, here we go. 15. All right, solve the following triangle. All right, well, let's draw it. So we know what we're dealing with. Standard labeling. Okay, whoops. I got all kinds of carried away there. Here is C, and here is B equals 5. All right, well, what do I have that I'm looking at? Okay, I'm looking at a side, and an angle. Okay, So, nope, I'm looking at side angle angle. All right, side angle angle. That's going to be only one triangle. Side angle angle is only one triangle. It's not ASS, this one's SAA. Okay, and you can probably tell that from our answer blanks, we were only going to have the one. All right, here we go. So I'm going to solve for A. I'm going to do 180 minus 40 minus 30. That gives me 110 degrees. There we go. Once I do that, I realize I have all the information I need for B. Now I can solve for side A or side C. And it doesn't matter who's smaller and who's larger because we're solving for sides. That's only an issue when we're solving for angles. So we can pick whoever we want to go first. Let's just throw side A on top of there. We'll put sine of 110 below it equals 5 over the sine of 30. And A is 9.40. Okay, we'll do the same thing for C. C over the sine of 40 equals 5 over the sine of 30. C is going to be 6.43. And we've solved it. Okay, so make sure that you are comfortable solving all these different types in different ways. The last two questions are on area. They're from section 8.4, that little bitty section about area. Remember, there's two area formulas that we use. We're not using the 1/2 base times height. So let's focus on both of those. We have a triangle drawn for us. We are given a side, an angle, and another side. All we want is the area. When we're given two sides and an angle, then you are looking for the area formula that contains sine. And remember, there's 3 versions, so pick the one that contains the letters that you have been given. In this case, we were given sides A and B, and we were given angle C. And all we have to do is plug this right in. So we're going to have 1/2 times 8 times 9 times the sine of 85 degrees. This comes out to be 35.86. Remember that K is their way of asking for area, and you don't have to worry about units, but they are square. There we go. Okay, last problem, thank goodness. And then the last 2 pages are just the answers. So remember, you always have those if you want to fall back on and check yourself. But practice, practice, practice your study guide. Okay, well, we don't even have a triangle here for this one. We're just given the information. And honestly, you don't even have to draw it. But let's go ahead and just throw it on there. Okay, we are given all the sides. And when you are given a side, side, side triangle and want the area, that's Heron's formula. Okay, for a side, 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 you're using Heron's formula. There's 2 pieces. First piece, you have to find the semi-perimeter. Remember that? You're going to find the perimeter and divide it by 2. So you're going to add up all the sides and half it. Second step is going to actually give you the area. It's a big square root. You're going to put that semi-perimeter in there. Then the difference of the semi-perimeter in every single side. And then you multiply those 4 values together and take the square root. So here we go. Let's find the semi-perimeter. We're going to have 1/2 times 20 plus 25 plus 15. I got 30. Okay. Now for the actual area, this is your Heron's formula. I'm going to have 30 times 30 minus 20 times 30 minus 25 times 30 minus 15. And there we go. Now you can put that right in your big graphing calculator if you want to, or we can clean it up a little bit, up to you. Multiply those 4 values together, take the square root, and we came up with 150 area squarea, so we have our square units. And that is it for your test. So again, please, please, please remember, you have 1 attempt at this test. You need to give yourself time to do the whole thing, all 15 questions. I had to put a time limit on it, so I put 2 hours. You cannot leave and come back to the test. You have to complete it in that one setting. Make sure you have good Wi-Fi. Make sure that you can get that completed. It's just going to give you a score. It's not going to let you look back at anything, but I will go back and check them for you because I want to make sure that you didn't miss it for something silly. So I will go back and check your answers. Also, remember, you have those homework problems that you can do. Those practice problems, that's worth 5 bonus points. So you do have all of those in there to give you your bonus points. Just let me know if you have finished any of those, and I'll make sure that I add those points to it. But that is all I have for you for this week. So make sure that you get your My Math Lab assignments finished. They are due Sunday at midnight. Your test is due Friday at midnight. So I did give you the weekend to get the rest of that My Math Lab stuff done. And then I will continue with videos for Chapter 9 next week. So hang in there. I miss you. Bye-bye.